Randy, it's been 2 months. Where have you been, mate? Damn, bro, I need a haircut. G'day laddies, I'm back after escaping a band of rogue lizards. Yeah, they held me captive for 2 months and forced me to do their taxes. As you can imagine, I wasn't exactly thrilled about that, so I killed them all and managed to escape with my life. So yeah, it's back to work on the game, I guess. As you recall from the last video, I went about learning how to draw pixel art and did up some assets for the forest biome. It turned out pretty well, so in the same sort of world building spirit, I decided that I wanted to do some more work on the world architecture. Since this world is going to be absolutely massive, I needed a more clever way of handling world data. Otherwise, everyone's computers, consoles, mobile phones are just going to absolutely shit themselves when trying to play this game. And that would be a no-no. So I went about thinking up a solution. First thing that came to mind was Minecraft's chunk system. In this game, the world is divided up into chunks of 16 by 16 blocks wide. So you walk along, chunks get loaded in, loaded out, depending on your render distance, I guess. I don't exactly know how Minecraft works, but it's like something along those lines. But Minecraft is only infinite horizontally. This game's going to be infinite vertically as well. So I went about implementing that, went through a couple of different approaches, of course, but that's just all part of the process. Got it working in the end. Yeah, nothing visually has changed whatsoever, but behind the scenes, this bad boy can handle infinity. Now, this game has been way too flat for way too long, so I reckon it's about time we spice things up a bit with a bit of height. Now, there's 2 approaches I can see myself doing. Have preset textures that somehow tile together nicely, or have the angle entirely adjustable and just procedurally generate textures for it. Now, while procedurally generating textures sounds like a lot of fun, it also sounds like it would be a shit ton of work, so shoo. Right now, every entity in the game is pretty generic. The only way of giving it some actual unique data is by providing it with some components. But what if I wanted to give an entity some data which wouldn't really make sense as a reusable component? I whipped up some changes to the ECS to allow for what I'm calling a unique entity. You declare it like this, give it some components, fill in some unique data, all set. In this case, I've made a ground entity with a specific incline angle, and Datadesk will just generate the entire backend for it automatically. Now, if absolutely none of that made sense, long story short, you can now change this thingy, which changes that thingy. It's basically magic. Now, with this new incline selector in place, I went to draw up some more fixed angles when I realized, yeah, this really isn't going to work whatsoever. The more angles I went to add in, the harder it was to get everything to tile together nicely. Now, I could just avoid this issue altogether by keeping it at a small number of slopes, but that would really hinder the believability of the world I'm trying to create. So a different approach is in order. Now, back to what I was saying earlier, procedurally generating textures for any incline imaginable. Now, that would be great, but I can do one better. Why not make every single pixel in the bloody ground interactable? You know what? Let's take it a step further. Let's make every single pixel in this world interactable. I recently stumbled across a game called Noita, which has managed to do something similar, but that game's entire premise is based around pixel simulation and interactions between various elements. This game won't have anywhere near that level of high fidelity chemistry focus though. I'm merely going to be using pixel simulation to model the ground, probably water as well, I don't know, we'll see how we go. But yeah, it's a really cool premise though. I just realized up until this point, the audio sounds like absolute trash, so my apologies. I really need to invest in a lab mic. Anyway, back to pixel simulation, all I gotta do is just slap a bunch of them together, boot her up, and So the resolution at a standard zoom is about 480 by 270 pixels. That's a few. Now, it's only the rendering side of things that's having any issues with this number of pixels here. Memory-wise, it can handle that much data without breaking a sweat. Right now, I'm just rendering all these pixels individually, which is a bit bloody stupid. A more efficient solution would be to just batch them all together into the one texture, push that bad boy up, and Bob's your uncle. Luckily, old mate Ryan's got a function in the renderer for us called TS2D texture init, I think, yep. That's the one. And we can use this bad boy to construct a texture with raw data. And would you look at that, it actually works. Wow. I'm just giving each of these pixels a bit of random noise, so that's why it looks absolutely disgusting at the moment. But I reckon now will be the perfect opportunity for me to learn how Perlin Noise works. For those of you who don't know what Perlin Noise is, it's basically random shit that looks nice. I had a bit of a gander at the wiki page for it, watched a couple of videos, and slapped together an implementation. It totally didn't take me 2 whole days to get this working. I don't really have a use for Perlin Noise at the moment, so I just use it to shade in this temporary ground for the time being. The ground is going to be looking pretty bland for quite a while. Eventually I'll write up some shader to procedurally generate the textures for it, but I've got no idea how on earth I'm going to do that, so that sounds like a plan for future Andy. Next up, I went about implementing collision for individual pixels. Got that working? Kinda. I tried not having the pixels locked to the grid so they could move around all smooth like, but that was a dumbass idea and it introduced a lot of unnecessary complexity. So yeah, in the spirit of simplicity, I decided to scrap all of it and start from scratch. I did a bit of browsing on the old interwebs to see if I could find any existing examples that I could just sift through, but then I stumbled across this absolute piece of work. I don't know exactly when this was made, it's got a ton of messed up characters in it, but my god, was this the sacred text I was after. Zooey mama. Fucking love those books. Introducing cellular automata. So how this essentially works is the world gets divided up into little cells, and within those cells contains some information on that cell's state, and with that information you can model all sorts of physical shit like
water, earth,
heat transfer, air pressure, flow, just about everything, mate. Now here's the real kicker: since this is a pixel art game, the cells can just be the size of a pixel. Now all of this sounds like a ton of fun, so I programmed in a little sandbox area for me to play God in, and using the Perlin Noise from before, I generated a nice little hilly area out of dirt cells. Now it's time to get the physics working on these floaty fellas. Luckily, the overly complicated code that I wrote earlier was somewhat salvageable, so this wasn't too much of a hassle, and yeah. Well, ain't that beautiful? Beautifully inefficient. It's using up practically 100% of the performance budget. Oh, and there it goes. Luckily, there's a ton of optimizations I can do to get this running more smoothly. But before I get onto that, I added in some height restrictions because, you know, gravity. And after a bit of tinkering, I managed to get things running a little bit quicker. Not quite as fast as I wanted, but at least it doesn't crash. I also went ahead and generated a larger area for this little sandbox testing thingy. Proper collision for the terrain is non-existent at the moment. I've just got this little flat surface from before, so that's what we're going to be working on next. Hang on a minute. What's that sound? Nah, mate, this shit's all faulty. We're gonna need to get rid of it. Comment you out, comment you out, comment everything out. Well, looks like my work here is done. Hang on a minute, you didn't even rework anything. You just yeeted my entire bloody physics engine. See you later, kid. This is gonna be the death of me. So the old system was pretty poorly designed. I'll spare you the details, but if Professor Rework says it's gotta go, then it's gotta go. So I did a bit of perusing online and locked upon this article series by a bloke named Randy. Nice name, by the way. And yeah, it seems to be explaining pretty much everything my small boy brain can't quite comprehend when it comes to physics, so yeah. That's lovely. Turns out he's also got a bunch of really nice single header libraries, one of which handles the narrow phase of collision detection, so don't mind if I do, yoink. So I spent some time reading up on the articles and restructured my entire physics system accordingly. So yeah, everything's nicely contained in this little physics body component, which you can just slap onto an entity like so. That's the data side of things handled. Up next, I've got to integrate this bad boy so we can actually move. To make something move, you need velocity. To get velocity, you need acceleration. Luckily, our boy Newt reckons F equals ma, so to get the A, all you gotta do is be like, oi, can I have acceleration please? And I pull an old switcheroo like so. Or you can just use algebra, I suppose. That's a bit of a pussy move though. Slap some force into the equation and BAM! We've got movement. Remember that library I was talking about earlier? Yeah, well, we just walk on over to him and be like, hey my man, are these two shapes colliding by chance? Oh yeah mate, here's some overlap data. Oh sweet as. Slap that bad boy into this whack-ass formula over here and would you look at that? proper collision. This is called impulse resolution, so if you want to learn more, it's covered in the first article of that series I mentioned before. So with this brand spanking new system, I went about mapping some colliders to the terrain height very roughly. You've also probably noticed by now, Randall, where's the friction at? This is unacceptable. Luckily, old mate Randy Gould's articles cover a nice solution of friction as well, so I went about chucking that in, and bada bing bada boom, my man won't slide off to his doom. I've still got quite a bit of work to do in order to get friction feeling a-okay, but I'm just gonna leave it at that for now. Thanks for watching, goodbye. Wowee, wasn't that a good video? If you thought so too, maybe consider smashing that like button over there. Or you know what, maybe even consider subscribing, that'd be kinda lit and epic. Jingle that little fucking bell as well. Didn't get to work on anything too exciting this month, unfortunately. It was a lot of infrastructure work and planning, so hopefully it was still somewhat entertaining though. I should have a new video out in about a few weeks. Just gonna be working on some cellular automata stuff. Got the groundwork in place for it now, so I'm just gonna crank out some functionality surrounding that. In the meantime though, if you want to support what I do, there'll be a link to my Patreon page. Somewhere, or just in the description, I guess. There's a ton of content over there, like weekly progress reports, monthly builds of the game, access to my source code, product key for launch, plenty of stuff. So yeah, if any of that tickles your pickle, then it might be worth a little look-see. Also, if you've got any questions for me or just want to have a nice little chit-chat to some of the other lovely folk of the community, then the link to the Discord will be down in the description somewhere as well, so there you go. Sorry this video took so long to get out. I was on holidays for most of January. Then when I got back, I had to move houses, so that was a bit of a mess around, but I'm back now, full swing, so expect more juicy content coming your way very shortly. Anyway, massive thank you to all my top tier Patreon homies, which are Azariel, Benjamin Simon, Chase Holiday, Doxel, Daedalus, Game Dev Goose, Hibble, Ian Wisma, Kushi Depp, Kay Selkie, Lucas Sass, Matt Wazola, Ollie Crossley, Philip Shadowfer, Sir Six, Spectres, and Stephen Saw. I have no doubt that I absolutely butchered some of those pronunciations, so I'm really sorry about that, but massive thank you. Wouldn't be able to do what I do without you. Hey, that rhymes. Same goes to everyone else who's scrolling across the screen right now, of course. I love you all. Stay safe, and I'll see you in the next one.